In this tutorial, we will be discussing different units of measurement in chemistry. So you deal with measurements on a regular basis all the time. For instance, what time you wake up in the morning, maybe how tall you are, maybe how much you weigh. These are all different ways that we can quantify the world around us. And dependent on your surroundings, you might be using different units of measurement. For instance, in America, we tend to use pounds, but in other countries and in the science world, they use kilograms. We might measure ourselves in inches or feet, while others measure it in meters. So dependent on where we are at the time, we could be using different units of measurement. So scientists use the metric system in order to determine so that we're all on the same page. They've then taken the metric system and modified it a little bit to create the international system of units for all scientists to use everywhere. These are shortened by SI units. Now, you might wonder why it's SI and not IS. That's because it was a European model. And so it actually stems from Systems Internationale rather than international systems. But anyways, the scientific community has then changed what the metric system offers as far as the units that we use. For instance, if we look at the metric system, length is in meters and the SI units are in meters. That's the same. If you look at time, it's also in seconds and seconds. There's no difference there. However, if we're starting to look at things like liters and meters cubed, there is a difference here. The SI community, the scientific community, has decided to go with meters cubed, whereas the metric system is sticking with liters. Now this affects you because as nurses, you'll have, depending on who you're working for at the time, you'll have some doctors that ask for mLs or milliliters of a medicine, and some doctors that ask for cc's or cubic centimeters. So they're both units of volume, and they're actually equivalent. Milliliters and cubic centimeters are the same thing, but it all depends on what realm your doctor's using. Metric system is grams, but then the SI unit is kilograms. Now in nursing, we actually deal with even smaller units, so we could deal with micrograms or milligrams or just plain grams. I have seen doctors' offices where you go in and they actually measure your height or your your weight in kilograms rather than in pounds. And so it might help if you know how to convert those back and forth real easily, and we're going to talk about that in just a second. And then temperature, degrees Celsius, is the common one. We're using Fahrenheit, which would be the English units. And then we have kelvins, which is the SI community, the scientific community. All right, so why do we tend to stick with the metric and not go with the English? Well, first of all, we're the only country that I know of that actually uses the English system. In addition to that, it's actually easier for us to do calculations in our head immediately while we're standing there talking to a patient, or we're standing there talking to somebody else in the scientific community. If you see here, 1 to 100 centimeters, 1 meter to 100 centimeters. Centi as a prefix means 100. No matter what, it doesn't matter what we're talking about. We could be talking about grams, so centigrams, it would be 100 grams. Or 100 centigrams is equal to 1 gram. It could be 100 centiseconds is equal to 1 second. 100 centimeters is equal to 1 meter. Centi goes with 100. Whereas if we look at meters and inches, we're looking at a very odd set of numbers. 1 meter to 39.4 inches. That's not as easy to calculate in your head. That's more than just moving a decimal place. Same with meters and yards. 1.09. It's a much more time-consuming and tedious process to calculate that. Centimeters to inches is 2.54. Now if we look at the milliliters and liters for volume, remember metric tends to deal with liters and milliliters, while the SI uses meters cubed. when we talk about medicine, we're typically going to be using milliliters and liters, unless for some reason your doctor still likes to use the term cc's. And it all depends on where they are in their career a lot of times. The older doctors tend to use more of the older terminology. So milli means 1,000. So 1,000 milliliters is 1 liter. Once again, that's far easier to convert than 1 liter and 1.06 quarts. The 1,000 is easier for you to work in your head. That's why we tend to do it. Although they equal the same amount. That's why we have an equal sign here. So 946 milliliters is equal to 1 quart. If we look at here, that actual amount in the graduated cylinder isn't going to change. It's just the number that corresponds with it. Mass, we have grams and kilograms. Kilo means 1,000. So there's 1,000 grams in a kilogram. This is a conversion that you'll probably want to have to memorize. And that's because I've seen in doctors' offices, doctors using both pounds and kilograms interchangeably. And it all depends on what they're doing at the time. So you're going to want to memorize that particular conversion factor. Right, so temperature, there's actually 3 scales for temperature. There's Celsius, Kelvin, and then Fahrenheit is the ones that is in the English or the standard units. So if we look over here to the temperature scales, this is where absolute zero is. This is the freezing point. Okay, so this is 0 degrees, and that's where ice is formed. Notice from here to here, this is the Celsius scale. If you drop 0 down to negative 273, that's absolute zero. The Kelvin scale actually starts at that point. So notice it's 273 degrees difference. And both scales is a 1-to-1 ratio. So every time a degree goes up with Celsius, a degree goes up with Kelvin. It's a complete identical scale, except the 0 has been moved. The Celsius scale, the 0 starts at the freezing point of water, where on the Kelvin scale, the 0 starts at absolute 0, where all matter stops moving. Fahrenheit has a very odd system of units. I don't know exactly the reasoning for the breakdown for how it does. It turns out to be 9/5 degrees Celsius plus 32. And we'll talk about that more in chapter 3, and we'll do some practice problems with that. But you'll notice as you're reading your biology books, it refers a lot to Celsius scales, whereas when you go out to the doctor's office, a lot of times they'll do in Fahrenheit. So this is another one of those conversion factors that you're going to want to have to memorize, so that way you are prepared for whatever's thrown at you. Seconds is easy. Time is easy. It's always the same. It's both SI and metric, and it's actually also the unit for English. All right, so let's go through these. We're looking for SI units. For volume, that's meters cubed. If you were looking at metric system, it would be liters. Mass for SI is kilograms. If we were looking at metric, it would just be grams. Length, in both scenarios, it's meters. For temperature for SI, it's Kelvin. If we were looking at metric, it would be degrees Celsius. And that's an overview of how the units.